Hi everyone, welcome to my video classes. Today, let us continue the discussion of chemical kinetics. I think you have watched my previous videos. Some of you have messaged and WhatsApp me your doubts, and some of you have informed me your homeworks. That's fine. If you are anyone hunting for solving homeworks, any doubts, don't hesitate to contact me. We will together solve all your issues. Okay, let us go to these topics. Unit of rate and rate constants. This is one of the simple concepts you must know from the topics. First, I will discuss unit of rate of reaction. This is a general equation for rate of reaction, change in concentration of reactants. Remember, reactants divided by time. Therefore, the unit of concentration is mole per liter. Sometimes it is used in molarity also, capital letter M molarity. Time can be expressed in seconds, minutes, hours and years. When we do the radioactivity of certain samples, where time is taken in years. Therefore, this is the unit of rate of reaction. It is always constant. Please remember it. Unit of reaction is mole liter raised to minus 1, second raised to minus 1. We generally, chemistry people generally use second raised to minus 1. Fine. Mole liter raised to minus 1, second raised to minus 1. Okay. Now, what is the unit tells you? What is the unit tells you? What is the information unit gives? It is the amount of concentration of reactant changed. Number of moles of concentrations of reactants changed per second. Very careful that. If you know the number of moles of reactants concentration changed in 1 mole, you can calculate the mass of reactants changed, volume of reactants changed. Please think about that. You will get such questions in competitive examinations. Therefore, you just think, just ponder a little more about these units. Now I will go to unit of rate constants. Unit of rate constant. Okay. Our unit of rate of reaction, mole liter raised to minus 1, second raised to minus 1. This is rate of reaction. For rate constant, we can write a general rate law expression. Rate law expression for the reaction. That is R is equal to K into A raised to N, where N is equal to order of the reaction. Now, this is equation for K. K is equal to R upon A raised to N. What is our rate of reaction? Its unit is mole liter raised to minus 1, second raised to minus 1. What is the unit of concentration? Mole liter raised to minus 1. Therefore, when N is taken, mole raised to N, liter raised to minus N. Therefore, our general unit for order of the reaction is mole 1 minus N, liter N minus 1, second minus 1. Fine. Therefore, this is the unit of rate constant. Unit of rate constant. Mole N minus 1, liter 1 minus N per second. Am I correct? I'm sorry, I'm really sorry. Mole 1 minus N, liter N minus 1 per second. Mole 1 minus N, liter N minus 1 per second. We can do some calculation, order and unit. Unit of K, rate constant. This is very important. Suppose this is the general equation. Please remember, this is a general equation. Mole 1 minus n, liter n minus 1. Fine. Suppose your order is 0. Therefore, you put the 0 here. Mole, a 0 here, liter raised to minus 1, second raised to minus 1. Okay. Suppose your order 1. Order 1. What shall be? 1 minus 1. Mole 1 minus 1, that is 0. Mole. Therefore, no value is 1. Here also 0. Only second raised to minus 1. Very important. This unit is independent of concentration. Independent of concentration. Unit of rate constant of first order, independent of rate constant. Now second order, mole, here second, minus 1, liter 1, second raised to minus 1. Minus 1 plus 1, suppose it's a plus 1, no need of putting plus 1 there, but plus, minus 1 plus 1, minus 1. Third order will be mole minus 2, liter plus 2, S minus 1. Fourth order, mole minus 3, liter 3, S minus 1. Do you get the idea? Suppose it is fractional order of, what shall be? Mole of liter minus of S minus 1. If it is 3 by 2, 3 by n is 3 by 2, therefore mole minus of liter plus of S minus 1. Okay, you get an idea? Plus of, minus of, minus of, plus of, minus 2 plus 2, minus 3 plus 3, minus 1 plus 1, 0 order, plus 1 minus 1. Okay, when you select the unit in multiple choice, it's very easy. Minus 3 plus 3 plus of minus of this, whatever number here, that magnitude will be here. That is matching. That is matching. Okay, the sign should be very careful. This is the unit of rate and rate constant. Okay, now I will go to another topics. We are going to discuss in detail of particular orders of the reaction. This is I am going to discuss zero order reaction. Zero order reaction. Right? Zero order reaction. What is zero order reaction? Reaction independent of concentration of reactant. The rate of reaction is independent of concentration of reactants. Whether you take 1 mole per liter, 2 mole per liter, 3 mole per liter, half mole per liter, 0.1 mole per liter, you will get a uniform speed. Fine. That doesn't mean that the reaction does not take place. One of the important example, heterogeneous catalysis, photochemical reactions. We already mentioned these examples. Then you may have a question: if these reactions maintain uniform speed, suppose a particular reaction has very slow speed, how do you improve its speed? Because you want fast reactions, otherwise you wanted to wait for a long time to get the products. That is unscientific. That is not profit. Therefore, you want to increase rate of such reactions. Therefore, in case of zero order reaction, its speed can be improved by changing the catalyst. Maybe surface area increasing catalyst, or it may depend upon the intensity of light. Photochemical reaction, we will discuss in details of photochemical reaction. Fine. Okay. Therefore, we can consider a reaction. consider a zero order reaction. Consider a zero order reaction. A gives B. I stated it is a zero order reaction. The rate law expression is R is equal to K into A raised to 0, which is equal to K. Rate constant. I stated it is a zero order reaction. That is why I put A raised to 0. Fine. Rate law expression is R is equal to K into A raised to 0, which is equal to K. Let me check whether the video is okay. Okay, fine. Yes. Now, I go to further details of zero order reaction. Integrated rate expression of zero order reaction. Integrated rate expression of zero order reaction is another way, mathematical way of expressing rate of a reaction. Integrated rate expression means it is a rate expression for a period of time. You will get the average rate of a reactions. It's a mathematical way instead of doing experiments. Therefore, consider zero order reaction, that is R is equal to K. Fine. A gives P, R is equal to K. What is rate minus dA by dt? That is our R, because A is the reactant. Minus dA by dt rate expression, instantaneous rate expression in terms of reactant, which is equal to K, equation number 2. You just rearrange minus dA is equal to K dt, equation number 3. Rearrange. Now, we want the integrated rate expression. This is a differential rate expression. The differential rate expression will be turned to integrated rate expression by integrating this. Minus dA is equal to K dt. We are integrating from A0 to A, 0 to T. What is A0? What is A0? A0 is called the initial concentration or concentration of reactant before reaction begins. Initial concentration. Whatever the amount you have initially taken. What is A? A, very important. Throughout the kinetics, chapter kinetics, you remember what is A. A is equal to amount of concentration of reactant remains after time t. Okay, after time. Suppose you have taken 1 mole initially, that is A0, 1 mole. After 20 minutes, 0.3 mole, 1 mole initially, 1 mole per liter, 0.3 mole per liter reacted. Therefore, this is A0. What is A? 0.7 mole per liter. Okay. A0 is, A is not 0.3 mole per liter. Not this, but this. Okay. Now we can integrate this. We can integrate. What you will get the integration of dA? That is nothing but A minus A0 to A is equal to k integration of dt is t 0 to t. These are the limits. Okay. Now you apply the limits. You apply the limits. Okay. Apply the limits. Therefore, you will get a minus a0. When you put the negative inside, you will get a0 minus a is equal to kt. One limit is 0. This is the equation 5. Please remember the number. I just wiped my earlier number. Please correct it. Fine. Therefore, this is the integrated equation. Integrated rate expression. But you should able to use in different forms. Another one is a is equal to minus kt minus a0. Fine. Minus kt plus a0. Equation number 6. Please remember. Another one, a0 minus a by t is equal to k. This is also. Or a0 minus a by k is equal to t. These all are zero order equations. Equation number 7, equation number 8. Please remember all these things. Okay. Therefore, you have a is equal to minus kt because you kept the a here. Kt minus a0 minus has shifted to here. Therefore, minus kt plus a0. Now, I introduce you another term. What is that? See this term. Half-life period. What is half-life period? This is represented by T1.2. Suppose your A0 is 1 mole per liter. Now it becomes A. A is equal to 0.5 mole per liter. 0.5 mole. You know, this A is equal to A0 by 2. The time taken, half-life, this is the definition. Time taken to react half of the initial concentration. That is half-life. Therefore, suppose it is t is equal to 0, this time is called t half. If you have taken 10, time taken to become 5. 150, 1500, 500, 250. That's called half-life. Therefore, at the half-life, at t half, a is always a0 by 2. Therefore, this equation number 8, this equation, that is t half is equal to a0 minus this a become a0 by 2k. That is the finally a0 by 2k. Very important. T half is equal to a0 by 2k. Let me check the video. Okay. T half is equal to a0 by 2k. Therefore, we have one more equation. T half is equal to a0 by 2k. Please remember all these equations. I request you, you should have all the equations in your fingertips. Then only when numericals, conceptual question comes, you can solve. Not only that, I don't recommend that you by heart the equations. Instead of by hearting, you understand the equations. Each equation tells you beautiful explanations, nice stories. You understand that. Normally students are by hearting that. That's not recommended. Now, you remember that. You remember this point. T half of 0 order directly proportional to A0. Very important point. T of zero order is directly proportional to A0 because 2 and k are constant. Therefore, if you remove this constant, you will get T of directly proportional to A0. T of is directly proportional to A0. Okay, but rate of zero order is independent of initial concentration. Now we can go to, I go to another topic, graphical expression of zero order reaction. Zero order reaction. I have seen lot of questions in various examinations about the graphical expression of order of reactions. Fine. Okay, first, suppose you have x and y axis. Here here rate of the reaction, here concentration. Concentration and rate of reaction. For zero order, how shall be the graph? The graph shall be like this. Okay, sorry. Rate can be here. Sorry. Concentration can be here, rate can be here. When concentration changes, you will get same rate. Sorry for confusion. Concentration changes, you will get the same rate because rate is equal to k, a constant. Fine. Rate is equal to k, a constant. Okay. Now, another graph, second graph, concentration versus time for zero order. Concentration versus time for zero order. Okay, this is our famous equation. You can use this equation. Concentration versus time. A is the concentration, A. T is the time. A0 is initial concentration, that's constant. Therefore, it is y is equal to minus mx plus c4. Fine. Therefore, you will have a graph like this with slope is equal to k minus k or k. Slope is equal to minus k. Right. Now, we can go to the next third graph. Concentration versus half-life of zero order. Concentration versus half-life. What is, when concentration increases, half-life increases. Therefore, you will have a straight line graph like this because T are directly proportional to A0. Fine. Therefore, these three graphs are very, very important. The graph will be given and then the question will be, what is the order of the reaction? Suppose they will give a graph like this. I will ask you, what is the order of this reaction? Okay, you should be able to identify it's zero order because it's concentration time. Concentration time equation for zero order is A is equal to minus kT A plus A0. This graph connecting to this equation. Now, I ask you a simple question. How can you make order of a particular reactant zero? Suppose you have A plus B gives B. You want to make this zero. It's zero order. That is, K is equal to A B raised to 0. Is it possible? Yes, it's possible. How? Taking B. Large excess. Large excess. Therefore, if you want to make the order of a particular reactant 0, you take that quantity very large. Then what happened? The concentration of that reactant will be independent of any rate of the reaction. There is one beautiful example in that case. That's called pseudo-order reaction. Pseudo-order reaction. What is pseudo-order reaction? It is the reaction where molecularity is 2, but order is 1. You know what is that example? Example is acid catalyzed hydrolysis of ester. Acid catalyzed hydrolysis of ester. Because if you write the rate expression of that reaction, K into concentration of ester, concentration of water. But water is 0, this is 1. Water is 0. Therefore, in the case of acid catalyzed hydrolysis of ester, order of water is 0. But if the molecularity is 2, because you have 2 molecules are there, separate 2 molecules, that is ester molecule and water molecules. Therefore, whenever you see a term in the question paper, that is, this particular reactant is large quantity, therefore, without any further thinking, you have to assume that its order of that reactant is 0. Okay? That's all this video. I think you have followed. Okay, if you have any doubts, please contact me. We can clear it. Thank you for watching. Have a nice day.